basically we have here three terms. I wrote here sustainability, we have development, and we have urbanization. And so these three are somehow connected. And yeah, and I put here one figure between urbanization and development. And yeah, you see in this figure that, you know, on the horizontal axis, we have the log of the GDP per capita. So if you want to take, you know, GDP as an indicator for development, and you see that those countries, so each dot is a country, that those countries that are more, have higher GDP per capita also tend to have more urban population. And so there's, you know, some connection, and I'm sure you, yeah, this is a very well-known effect that, you know, with ongoing development, more people migrate to the cities, and so urbanization becomes more pronounced. Then we have between sustainability and development, we have sustainable development goals and sustainable development. And now the question is, what is between sustainability and urbanization? So this is what we are interested in. And this turns out not to be so trivial, so not so clear. Yeah, so you can talk about, you know, urban sustainability is the increase of efficiency, of resource use, optimization. Important dimensions of equity and social justice are sometimes not included. Then there's other concepts, you know, like urban resilience, recovery from disaster events. Urban transformation is like large-scale changes in system properties and so on. And yeah, so it's not so clear. Urban sustainability, sustainable cities, resilient cities, smart cities. So there's a very, you know, big body of literature from different disciplines, and in my point of view, the concept is challenged because of 2 points mainly. So the first one is cities are not a closed system. So if you look at one city, you know, you have still like a lot of flows in and out. So you have people that go in and out. You have you know, materials like water. You have energy going in and out, and even, you know, air, like you know, temperature, and so that it's basically an open system. It's the opposite of a closed system, and actually it's basically only characterized by high density of people and infrastructure, and this high density, of course, also attracts the flows. So this makes it very difficult. So and you typically one cannot, you know, look at an isolated city. Yeah, and then the SDG 11, which is dedicated. This includes many indicators, targets, which have an emphasis on development and less so on sustainability. So we have so cities are not a closed system, so they are open, and you know, we have inflows, outflows. And then if we take SDG 11, so which is about sustainable cities and communities as a standard, we have, you know, many indicators which have an emphasis on development. So there is things to, you know, convenient access to public transport, and yeah, and you know, and many of them have like a local focus, while sustainability is a global issue. So two hypothesis approaches. So if we assume that each city and settlement is more sustainable, if each city and settlement is more sustainable, then also the entire system is more sustainable. And then, you know, it's trivial, and we, you know, we wonder, what do we need the city for? You know, if we, you know, I use this example often of you know, the windows we have here we have this double glazed windows, or sometimes even triple glazed. So this means you have like two layers of windows, and in between, you know, we have an isolating, you know, air pocket. And so this these windows, you know, they work the same in the city and in the rural areas. So this is something, when you think about the city, you don't actually need to look at the cities, and that's why. Yeah, that's why if we talk about urban sustainability, in my point of view, one needs to look only at what the cities do. Yeah, and then there's this other thing, that urban form of living is more sustainable. So this is like a hypothesis, or in other words, is one big city more efficient than two cities of half the size together? So this is actually the, you know, the key question that that I think needs to be addressed, and it is not solved in my point of view by science. And okay, this is basically what I said. So what is the benefit of the city? And often we have conflicting goals. So this is also an important issue in my point of view. Let's say if we have a very compact city, we have short distances. So this in a sense is good. But then in summer, we have a lot of heat island intensity. I don't know in your cities if this is also an issue, but in European cities and also in with ongoing climate change, the summer heat, the heat waves and the heat island becomes a very big problem. And on the contrary, you can think of an organization where you have more sprawl, where you have less dense cities and sprawled cities, and but then you have less heat island. You can have a lot of green in between, but then you have longer distances. So it's kind of difficult to to find a trade-off between these effects, and this is just two examples. Okay, I want to give you one example also on urban carbon emissions. And so what we did here, this is some of our work. We looked at population. This is the blue stuff in the left, and the carbon emissions, the CO2 emissions on the right. This is the red stuff. And now we wanted to relate them. So this is gridded data. So there's a square grid, and for each pixel of this grid, there's one value, and we combined them. And how we did this was by so-called Lorentz curves. So this is what we have here in this example. So basically, we take we sort the pixels by the population. So you let's say you make a long list, and in the list there is each pixel, and there's the population, and we sort it from lowest to highest. So on the left are the pixels with least population, and on the right with most. But then we do it cumulative. So we add it up. So we start a sorted list, and then we add it up. And in the same rank order, we also add up
some connection problem, looks like
cumulative carbon emissions. And so this means that we can. Okay. So we have this red curve, and this means with very little population, we already have a very like a considerable amount of carbon emissions, and only if we include all population, we reach the total carbon emissions. And this is an example for the US, and we can do this for other countries. And when we look at UK, it's a similar shape. Brazil is a similar shape. France, it gets a bit flatter. Germany is almost complete straight. China is the opposite direction, Kenya opposite direction, and Uganda opposite direction. And this means, for example, if we look at Uganda, we can take 20% of the population, but have almost still 0% of carbon emissions. And if we take 80% of the population of those least populated pixels, we have not even 20% of the population of the carbon emissions. So only at the end we have the rest. And this means that in these countries like in the US, the carbon emissions happen more in the rural areas and in the less dense populated areas, and in countries like Kenya, Uganda, it's more in the highly populated areas. And this led us to compare this with the GDP per capita, and we use a Gini coefficient. So basically, the shape of the curve can be characterized by Gini coefficient, which is used often to measure inequality. And we extended it. Usually it goes just I think in the blue corner, but you can also define it for the green corner. And then when we plot this Gini coefficient as a function of the GDP per capita, we see that there is some correlations. So the countries with higher GDP per capita tend to have the curve in one direction, and those with less GDP per capita, it's in the other direction. So this means that in the more developed, if you take the GDP per capita as a measure of development, then the more developed countries, the emissions happen more in the less dense populated places, and in the more developed countries, less developed countries, it's in the densely populated areas. And yeah, this is quite interesting, and the question is, why is this? And this is ongoing research. I want to give a bit of yeah, also ideas, you know, for in direction of technology. So what is emerging now kind of is 3D printed houses, 3D printed constructions. And so basically the idea is, you know, probably these 3D printers where you have some, you know, some plastic which is placed, and you can basically generate yeah, 3D objects. And the idea is to apply this technology to housing. And there's yeah, different approaches, and there's several houses that have been built. And this is an example which I show because the material used here is not concrete. So most of them use concrete, but this example is using clay. And yeah, and this is, you know, a nice way of alternative construction. And yeah, we actually wrote a paper on this and found that at least in comparison to European buildings, the 3D printed houses are more efficient in terms of carbon emissions. Yeah, another technology that you know, these are just, you know, some examples of things that one can think of, is this thing here. So it's called Selector, and the idea is to have, you know, some small boxes here on top of the houses, of the buildings, which collect the sunlight, and they you know, they bring it with fiber cable into the rooms. So and the nice thing is that, so you don't need, you know, during the daylight electricity, because you use you know, the sunlight. And the good thing is that it filters out, you know, UV light and infrared. So you don't bring the heat you know, from the sun, you bring only the light. And they say that so like a quarter square meter is equivalent to 5 square meter of artificial light via photovoltaics. So it's, in a sense, it's 20 times more efficient. But of course, you know, it works only when you have daylight. So if you know, so it can be only complementary to electrical light. Okay, then I would move on to adaptation in cities. I don't know how we're doing in time. Yeah, so I like I focus here on nature-based solutions. So the idea is, you know, we have climate change, we have climate change impacts, and so we're gonna expect more yeah, natural disasters, floods and heat and these kind of things. And now the question is, how can cities adapt? And yeah, nature-based solutions, as the name says, you know, tries to address these problems with yeah, with nature. And and here are I took this from a report, different options. So we have parks, forests, tree trees, green buildings. So we have green roofs, green walls, and we have things for water management, bioswales, and what this means I come to in the next slides. And the benefits are, okay, we have cooling air temperature, you know, from the trees and the vegetation. We have regulation of water runoff, so the, you know, the bioswales, biodiversity and human health, you know, these are positive aspects. And the climate change impacts are mostly, yeah, the floods and the heat stress. And yeah, these are like bioswales. So the idea is that you know, you build next to the street some kind of you know, like these slopes, and you know, this how do you say, like kind of yeah, like small rivers, or yeah, like how do you say, like a channel next to the street, and where the water can flow and can infiltrate into the soil. Otherwise, you know, and how it works is that if everything is sealed, you know, the water goes directly into the canalization, and often if there's a strong rain event, the canalization cannot cope with the amount of water, and then you know, you have like the flash flood and flooded areas if there's like an extreme rain event. And then you can also have like check dams. These are small dams which you know, then also benefit or support the infiltration. Yeah, and then it can also be grass and so on, and this is, you know, can be public green space. So there's a lot of benefits. There's also problems. You know, for example, you have that in the city people throw trash and then you need to collect it and so on. And this is more difficult when you have things like this than when you just take a machine to remove the trash. Yeah, so this is one of the disadvantages. And then also the vegetation might need some maintenance and so on. And this is an example. So this is from Canada. On the left is more like a retention pond, where the water from the can accumulate, and instead of flooding the street, you already built some small pond where it can go. So this is the idea. And on the right hand side, you have these swales as I discussed them. And yeah, of course, it depends a lot on the the conditions in the city, and if you have inclinations, you need different things. And but this is the basic idea. Yeah, then there is ideas from planning, and I like this figure a lot here from Urban Climate, a book by Oke, who works on urban climate. And they pose the question: so you have, like, let's say 1 hectare, and you have 17.5 units to be placed on this hectare. And now you can think about the configuration, how to do this. And so in the top left, we organize them in a high rise, and then in the middle we have like houses in rows, and in the C in the lower right we have more like yeah, disorganized arrangement. And now the question is, okay, what is good, what is bad? And yeah, and we can, for example, they say that we have like this tall building, and then we have yeah, more surface wind because there's less structures, less roughness, but we have an efficient land use. So we have on very small land we have a high density, and the space around can be used not only for parking as it is indicated, but also for vegetation and trees and stuff. And yeah, so yeah, and then similarly, you have these other examples in the row houses. Here you have, everyone has its own garden, and so on. So then, yeah, so these are like different configurations, and I think it's kind of interesting to think about, what is best, in which respect, which goals can be achieved, and so on. And click. Yeah, and conclusions, that can be drawn is that there's no single best design that meets all climate objectives. So, this kind of, I already indicated before, that you always need to do compromises. By doing one thing, you will be worse at another objective. Yeah, and then there can be also different different strategies that lead to the same objective. And then what is also important in terms of cities, when you have one design option, then later you cannot, it's hard to change it. In particular, more in the in the bigger planning, you cannot completely demolish like a neighborhood. It's very, once the infrastructure is there, it's can hardly be changed. Yeah, and planning criteria can generate different forms. This is clear. Yeah, and now coming more to practical street design things, and so here they address different parts and different components. First one is temperature control. So if you want to reduce the temperature in the city, they suggest, okay, to use reflective roofs, to have maybe a fountain, okay, street trees, green walls, and so on. So this is what, at least in many climates they say. Do we have colleagues from Bangkok or so? I didn't, because in tropical climates, all these things are a bit different. Then wind control, so they suggest to have buildings of similar height, so that the air doesn't, the wind doesn't get stuck in the street canyons. Also street trees, and then the next one, yeah, air control. Okay, this is also clear. Then solar control, so to enable shading, to have arcades, window blinds, solar panels, and these kind of things. Runoff control, so to use green roofs, use some permeable paving and water storage. And here I need to say that, you know, the green roofs, that they might be also kind of competing with photovoltaics. Yeah, here are examples from you know, green facades. So there's a lot of different ways of doing this, and different you know, species of plants. So I think that, you know, at least in Europe, there's a rather good understanding what can be done, and there's actually a nice example in Italy. It's called Bosco Verticale, which looks a bit like this. So where they plant really like small trees on the balcony, and so this, yeah, to yeah, generate some, you know, forested building in a sense. But I guess that in, you know, in other countries, other places, you know, the vegetation must be, of course, different. Yeah, then as a bit of an epilogue here, two popular developments that I observe, namely yeah, urban green. So as I mentioned, the Bosque Verticale. Then the other development is car-free cities or super blocks. So this is something that that is being promoted, for example, in I think this image is from Barcelona, where they, you know, Barcelona has a very regular structure, and they combine the blocks into so-called super blocks, where in between there's a very strong limitation on the car access. And yeah, by this, you know, the street life, you know, becomes a very different one, because the people can move on the streets and they are not permanently yeah, threatened by cars. And yeah, and then urban sustainability and sustainable development goal 11. And now I would like to go to some group work. And I don't know, Professor Dacker, can you, what I would want to do is to, yeah, to look at SDG 11, and therefore the participants, I think, how many participants do we have?
Okay.
Something like 20, less than 20. And so the idea is to organize them in 7 groups. Can we do this?
Yeah, but how to make a group here?
Usually they have option to, you know, to
Yeah,
shuffle
yeah.
into 7.
We do have options to make a group. I have not.
But before you start, let me explain what they should do.
Yeah.
So
Maybe we can make groups. So
okay, then let me first explain. So basically, I want you to have a look at the SDG 11. So this is the, you know, the sustainable cities and society communities, and basically I want you to read the goal. Let's say if you are in group number 1, then you should read 11.1. If you are in group 2, then 11.2, and so on. So you should you know, summarize the target and the indicators possibly. Then think about which parts of the, you know, of the target are more like about development, and which are more about sustainability, and which has more global or local effect. And then if you think about, you know, what is missing, and then you find the SDGs. So basically, you know, if you very roughly want to, you know, summarize the SDG 11, so we have the first one, which was about housing. Second one is transport, so public transport, planning, some participatory planning. Fourth is about heritage. Fifth, which we didn't hear, is about disasters. Six is about environment, pollution, waste, and the seventh one is about public space. And then there's 3 other, let's say, sub targets: regional development, disaster risk reduction, and development aid. Okay, and now just a few more slides on the interactions. So yeah, we can, I don't know if you heard presentation by Prajal, so they he studies a lot, you know, the interactions of SDGs, and one can also look at the you know, from SDG 11. And here what we see is basically the blue is the synergies. So whenever like SDG 11 has, let's say, in the indicators goes together with the other SDGs, then it's blue. If it doesn't, then it's red, and the yellow is, you know, undecided. And we see that, you know, SDG 11 kind of goes more or less together with all of them, and it's a bit more synergy than trade-off. So the red one is trade-off, and so it's an you know, a bit yeah, complementary goal in the bigger picture of the SDGs. And now if we look at a bit more into detail the targets with which the you know, SDG 11 interacts, and we have again on top the positive and in the bottom the negative, and I have also different representation in this one. So we see on top we have the, you know, the synergies. We see that, you know, SDG 11.1, which was about the housing, you know, interacts with many other positively many other targets of other SDGs, and also a bit there, but less prominent, is 11.6, which was the, if I'm not mistaken, 6 was the pollution and waste. So this means that, you know, if we kind of address the housing and the pollution, respectively waste, in the cities, we also have benefits with other SDGs in a sense. So this is very, very nice. And yeah, and then we have in the bottom side of the picture, we have the negative correlation, so the trade-offs. So in there again, we have target 11.1 with a bunch of others from targets from other goals, but this is like less pronounced. So the most important are really these ones here, 11.1 and 11.6, the housing and the waste. Yeah, and with this, I would like to thank you for your attention.